Hi, it's repair time, and well, it's a pretty decent sized repair today. Look at this. It's a JBL Partybox 310, one of these portable party goer speaker things, karaoke things, or like for, any sort of muso out in the field, battery powered jobby. Absolutely enormous, and it's reported to be faulty. Now, it's obviously had a fair bit of use. I think the rubber baby buggy bumpers have come off here. These look like the screw holes. It's had a good life, and it's got wheelies like a suitcase. We've got a mains input there. And behind here, there's a whole bunch of inputs, and yeah, it looks like we've got, two mic inputs there, and we've got a USB port out there, TWS, don't know what that is, and a daisy chain thing, so you can get daisy chain multiple units. There's all the details for those playing along at home. And on the top here, you can see that we've got one of these flip-up handle things, so that's really nice. We've got a big fat carry handle here. Not sure what that does. I don't know, you put something in there maybe. Power charge level, because it has an internal battery. You can use it out in the field when you're busking or whatnot. It's got the Bluetooth, the USBs, and bass boost and disco party lights and stuff like that. And if we plug it in, you can see power indicator there is orange, and that there's a LED bar graph there, which is almost full, which indicates the internal battery charge level. I don't know what size internal battery it's got, so that indicates that the mains power supply is okay. It's getting to the logic and charging stuff, and it is sort of like flashing there as if it's full, and if I leave it in this state, it'll just completely switch off. So I assume that the battery charging mains power supply seems to work. I thought when I got it that would be the initial fault. Oh, there's something wrong with the mains power supply, or the battery's gone cactus or something like that. It doesn't start up at all, and if I disconnect it, it doesn't start at all. No amount of like holding this down for 10-20 seconds does absolutely nothing. I've tried various combos of switches and stuff like this. I can feel a tactile click in there, so I'm getting the click, but it's not coming on, so maybe it just could be as simple as, the power switch is buggered, maybe. The only other thing I noticed is that the echo minus button doesn't press at all. The others have a tactile dome feedback click, but that one doesn't. Like, even if that was jammed on, then that shouldn't impact the power here. So, yeah, I don't know. So if I'm lucky, it's just going to be as simple as maybe a power switch, but it could be something more complicated. Maybe I have to disconnect the battery and like to reset the processor or something, the standby processor or something like that. Perhaps. I got no idea. To match my comically big repair item, I've got my comically big screwdriver. Look at this. So let's get in here. I think they're Phillips. Yeah, that's engaging. Looks like, yeah, not metal threaded inserts. So they've got these screws on both sides. So these side panels just come out like that. I really like that. Although that being said, on the back here, there's suspiciously these look like hidden screws behind there. So I might have to get the knife under there, but I'll try the side panels first and see what we get. No, this panel doesn't want to seem to come out, so I'm thinking that this back has to come off first, and then maybe that'll lift out. Oh look, I found a little thingo on the bottom behind here. Is that put on a giant speaker stand thing? Yeah, that makes sense to like prop it up higher. There's 4 really deep inset screws in here. I'm not sure if I have to get those out. Aha! This isn't a cover. This is fake. This is all integrated with those screws on top there. Aha! I was wondering why this wasn't this top part wasn't coming apart at the sides or anything. Yeah, there's little hidden caps again. So it looks like there's 3 screws there. Oh, and it just dawned on me what this slot is, of course. It's for your shoe phone. So you sit your shoe phone or your tablet-y thing on top so that you can play your disco-y tunes with your Bluetooths. Turns out there are some screws under these little plugs here, so I'll get those out. Sneaky buggers. Look at this. Cover here with a couple of more screws. Unbelievable. This thing still wasn't coming apart. Found a cover here which looks like it might actually come out. Oh yeah, look at that. Yeah, there's more screws. Unbelievable. So this is really a multi-step process, and pretty much you're going to like lose the glue on all the stuff, all the feet on the bottoms. This one's not in pristine condition. If you had one in pristine condition, yeah, you might be re-adhesiving. Is that a word? You'd be putting adhesive back on. Yeah, JBL, they make good stuff. I do like their speakers. I've got a whole bunch of JBL speakers on my daily drivers. But yeah, geez, they don't make it easy to get into it, that's for sure. So this plastic cover, with a bit of effort, looks like it's going to come off. Oh, there you go. Well, it's one gigantic speaker box, and they do have nice sealing there around the ribbon cable. And yeah, you've got to like pry these out because they've got lips on there, but once you do, that side cover's coming out. There you go. Once you're in like that, you can see that looks like that grill was never going to come out there because that's all integral with this plastic thing here, which is then screwed in. And you've got one big, looks like chipboard box here, but you don't expect anything better than that. Yeah, once again, you've got to pry that. Oh, there you go. It's just one ribbon cable going over there. And, oh, there you go. Single-sided jobby. Look at that. So there's our front panel board. Anyway, the attention to detail on the acoustics is quite nice. They've got foam padding over all of the wires in here just to prevent them shake, rattle and rolling in there. But like I said, you could have some sort of like, you know, software, firmware lockup on this thing, and you may have to like disconnect the battery to, you know, cold reset the damn thing or something like that. So if it just like magically comes good when I disconnect the battery and hook it back up, yeah, that'll probably be the reason. There's our buttons and our PCB. Yes, they are little just PCB mount tactile buttons. Those little surface mount jobbies, not exactly the most reliable things in the world. I'll get a meter on that and make sure it buzzes out. Now I've got to figure out which switch is what. Yeah, there's just one little micro in here. Whole bunch of passives. Not entirely sure why they went with two separate PCBs there instead of one, because you've got to do the whole ribbon cable thing to join them. I don't get it. Different model, maybe? I do believe it is that one there. Third hand. Whoa, hang on. I'll get it in fourth hand. Yeah, there we go. Nah, it's good. That's consistent every time. So yeah, it's not the button. All right, rule that out, but that was a good first guess. But that Echo minus button that I said had no click on it, sure enough, there's no click. I mean, this is not feel-o-vision, but trust me. But obviously this chip's working because here's the bar graph LED indicator here. That's all working as it should. You know, the power lights up orange as it should. So obviously data's getting to this chip and it's lighting up the LEDs and everything's hunky-dory. So, but that one is definitely, I wonder if is that actually permanently shorted? No, it's not. So it's open. So that shouldn't cause a problem. As it turns out, that button actually still works. It's just lost its snappy tactile doneness. So I think for now it's safe to rule out anything on this top board because that power button works and everything that should be getting a signal back. I mean, I can have a closer look under some magnification here, but I doubt anything's wrong in that regard. I think our problem's somewhere else. And given that this has 4 red wires and 4 black wires coming out of it, aha, the battery is on the back of there. 72 watt hours. There you go. That's smaller than I thought. Not sure how many hours you get out of this playing your doof, but oh yeah, I'll put up the specs. Oh, well, that was very unexciting. There's the acoustic filler in there. Good thing is, I guess you could relatively easily replace the battery pack. Would have been nice if it, like, externally accessible. That would have been great, but okay. The other interesting thing is, yeah, the mains input also goes into the acoustic box. Oh, apologies to the JBL engineers. No, of course not. There it is. The mains power supply is actually on the top. And we've got our amplifier board here. Of course, none of that Class A rubbish. Class D all the way with LBJ here. So these would be our speaker drivers left and right. That'd be our tweeteries. So yeah, they've just put that mains connector on the back there just for convenience, really, having it down the bottom, because you don't want the mains cable up the top. In fact, that's a good touch. Now that I think about it, when this thing's standing up, you want the mains cable down near the floor. You don't want it coming up and then plugging in the top. So yeah, I can see why they did that. So yeah, hats off. I think they were thinking there. Anyway, there's no obvious signs of distress on the like physical distress. There's no bulging caps or anything. Everything looks, the magic smoke hasn't obviously escaped anywhere, but as I said, it looks like the mains power supply works just fine. And now we can get to the golden rule of troubleshooting. Thou shall measure voltages. Oh yeah, there's our Bluetoothy thing, and that goes up to the Bluetooth antenna, which just sticks on the top here, but it's very simple, isn't it? Like the little board-to-board interconnect there. What are we getting out of that? 24 volts? Yep. But as I said, first thing I'm going to try is I'm just going to disconnect the battery, because I can't see, there's no obvious like reset switch here or anything, because this is obviously standby power to that front panel board, because this is a soft power thing. So yeah, if there's no reset, I'll just disconnect the battery, and that should just reset the power to the whole thing, and just check, see if that does anything. Plug my ribbon cable back in. I think that's around the right way. Let's plug our battery back in, and don't put any stress on that ribbon cable. No, it's still dead. Scratch the like firmware lockup idea, I guess. Oh well, once again, that was a decent hypothesis. Just plug the mains back in for a sanity check. Yep, lights up orange again, and almost full bars on there, so it's working exactly like it was before. And what is the battery pack? 8.3 volts. There you go. So yeah, battery's fine, as the indications suggested. Something to do with the processory board, probably, because this should work, of course, independent of the mains power supply. So if the mains power supply's failed, it shouldn't matter at all. Now, the great thing about this is that we can just easily remove all the boards and work on them on the bench here. So I've got the two front panel boards, and I got the main board out here. It just had 5 screws in it here. Of course, heat sinking on the bottom, because this is these are obviously Class D amplifier chips here. Heat sink pads, which is why there's just some residue there. So that's no damage to the actual chips. Now, I've actually been around the board, and I haven't found anything obvious. Of course, you want to do a visual inspection. There's no like blown parts or anything like that. Have they had the numbers rubbed off, or is that also some, I don't think they're heat sunk. Anyway, it's a couple of missing parts, but yeah, I've looked over this board and I can't see anything. I mean, here's our external coming from the external mains power supply. That obviously works, because you've seen when we plug in the mains power, not only does it have the correct indication for charging the battery, it also shows that like it's full, and sure enough, you measure the battery and it's full and everything. So when we plug in the mains here, so this is the input here, we just got 2 parallel diodes there going to the vias down the bottom there, and they pop out here and they go into that, yeah, in the positive side of the cap over there. And obviously that's getting through to the processor, which is going to be under here. Sorry, it's soldered down, I can't show you, but and then it's going out to correctly drive through this ribbon cable all of the board and everything, right? But the strange thing is, it doesn't seem to work when you plug in just the battery on its own. There's absolutely no response here whatsoever. And of course, we've got the battery out too. Nominally, max voltage 8.4, I think it's measuring about 8.3. So as indicated by the charge indicator, it is fully charged. So we can just plug in our battery here. We can't get that the wrong way because it's keyed. So no wuckers. And we plug this in and we can start tracing voltages, but we get nothing. I plug the power button over here and like there's absolutely no indication that this is working at all. And we know that is a fully charged battery, and I can measure that. You can see that's 8.3 volts, right? Okay, where does it go? Looks like it goes over to these points here. And this is where you just start, thou shall measure voltages, and start tracing them down. Because I think if we go measure that keyboard board, I reckon there's no voltage getting to that board, but we'll get there in a minute. I just want to make sure. So this is ground plane here, and this is our input volts. Okay, so we get now 8.3 volts. And that's going through to parallel 20 milliohm resistors. So they've got a 10 milliohm current shunt there. So our voltage is getting in there, and our voltage is getting to the other side, okay? So those current shunt resistors aren't blowing. And this chip looks like a MOSFET because all 4 pins are shorted together and 3 pins over here plus the gate drive over here. Okay, so we get now 8.3 volts in, and are we getting our 8.3 volts out? We are getting our 8.3 volts out, so that MOSFET is switched on. No wuckers. Actually, these all look like MOSFETs. So there's a lot of switching happening here. It comes into here, and it looks like, you know, it's switched through to here, then it looks like it switches through again to here, and then it looks like it switches through from here, which then goes off to this boost converter over here, but it also switches over to here. So there's a lot of switching here. So this is obviously the switching circuitry for the, like the mains input, but the pins are all the way over here, like this. So I don't know, yeah, they're just like on the opposite side of the board. So I thought it would switch between sources there. Okay, so we've got 8.3 volts there. Okay, this MOSFET is switched off. So it's coming in here, and then it looks like it doesn't go anywhere else, does it? So, yeah, it is switched off. And our gate drive there, we'll find that we won't have any voltage on that gate drive. So, and then there's no voltage going through to here. So this DC to DC converter is not switching on. We've got another couple of current sense resistors over here. Actually, the current sense amplifier is probably inside the switching converter here. So I don't think there's much doing on the other side over here. No, got another switching converter over there. I don't think that's got anything to do with anything. Yeah, so it doesn't seem to be going off anywhere else. I think it seems to be like either that MOSFET's failed or it's deliberately switched off somehow. Here's this ribbon cable. Okay, I've reseated these ribbon cables. They had tape on them, so I've taken those off and I've reseated them, and it still makes no difference. So it comes through here. There's no active circuitry on this board here, like this, just a whole bunch of jumpers. So it goes over to here and daisy chain. And for some reason, this one is upside down compared to that, but that's how it was. I swear, I didn't put that back in the wrong way. So the only processor we've got here, and we know this works, we know it works when we plug in the mains power. It's a W50463729. I search for W5046, you get nothing. I don't know, some little custom-y thing. Any major bypassing around this chip, that's basically it. And there are fat traces there for a 0 ohm jumper, so I assume that's kind of like power raily. I have never seen so many 0 ohm jumpers before in my life. Count them. All because they wanted to avoid a double-sided PCB, the cost of a double-sided PCB. Anyway, the only capacitor I can see is there, and that's got 300 minus 300 millivolts, 300 millivolts on it. So let's see if we can replicate this by feeding in our voltage here and simulating our mains power supply. I'm not going to go get it out. You know, it's dangerous to have the exposed power supply. I'll just hook a bench supply up to it. It's safer. We can current limit it, you know, everything else. And we've got a nice header there that we can plug into. So yeah, let's do that. See, 24 volts is marked on the mains PCB. I believe I've got that correct. Sanity check. The white positive goes over to the 2 diodes there, and the other black goes down to ground plane. So, yep, no worries. So I'll set the current limit to very low, 0.1 amps, so that's only 2.4 watts. So, you know, it may not be enough to, because it's going to try and maybe charge the battery or something, but that's what I want to see. I want to see if this sucker lights up. Constant current, yep, see? Look. Oh, look, yeah, and it's not, yeah, and it's doing the charge thing. It's trying to do the charge thing, and it's dropped down to 15 volts, yeah, because it's current limited, see? Yeah, great. we're duplicating, actually, right? Because we're duplicating what we got over there. The worst thing, if Murphy's around, then, yeah, you get it on the bench and you got entirely different symptoms. And it's still doing that. So let's actually disconnect the battery, and let's power it on again. There, right? There we go. And it's not drawing much. It's only drawing 48 milliamps, right? And I press that button down. That is the power button. And it's not switching on. So if it was switching on, I would have expected the power to, the current to increase there. The LEDs are going to be 10 milliamps a pop, but not from the 24. obviously, because that would be scaled down. Now we can flippity-doo-dah this back over and go back to probing this. And yep, we're getting our same 8.3 volts. There you go. So the 24 volts that's coming in, it's being converted somewhere. It's giving us that 8.3 volts, exactly what we were getting from the battery. Now 8.3 volts is getting there. Now it wasn't getting here before. Why is that? Oh, over range, 1 volt. No, auto range. What? How is that over ranging? What's going on there? Over range. There is, I've got auto ranging measurement set. Yes, auto please. Give me 100 volt range. What the heck was going on there? That's my National Instruments thing. Just plain silly buggers. I don't understand why that shows over range. Anyway, that is super strange. I'm going back over here to measure my caps. Ta-da! 5.2 volts. There you go. So I was right before. That, yeah, there's simply no volt. When you plug in the battery only, there's no voltage getting to this processor board. But that doesn't explain why this doesn't like switch on. I expect it to, like, you press the power button and I expect it to do something. To drive this like multiplexer, keyboard LED multiplexer-y thing, right? You know, there's got to be a processor working somewhere. We've now got our 5 volt rail. Didn't expect that. I really expected, once I got the voltage onto this board, I expected this thing to power up. So it's an additional troubleshooting complexity. Great. There you go. We've got 18.4 volts over here. That's interesting. Stupid over range again. What? How can it be over range? And if we probe that point there, we can see that, yeah, we're getting our switching waveform there. So something's switching around here, and we're getting our 5 volts over on our main board, and everything seems hunky-dory. There's our 24 volts input, okay? And then on the other side there, our switching converter, which is on the other side, that's 8.35, that's the 8.3 volts. So that is our charging circuitry for our battery. This is a MOSFET. This is not the charge controller. Once again, 4 pins shorted, 3 pins over there, plus a gate. But if I up my current to like an amp, and then I plug my battery in, there you go, 200. Yeah, it's charging. It's showing the LED indicator over there. Trust me. So, and these LEDs will eventually go out because it'll deem it's at full charge and whatnot. So, yeah, yet if I press that power button, nothing comes on. Yet we know that switch is good. Okay, we've got a switching converter here. It's got 24 volts on the input and the output, 18.6. Okay, I guess. Plug the battery in. Let's see if we get the same thing. Sanity check, 24 volts, 18.6. Okay, so with or without battery, that regulator is regulating, I guess. Of course, we don't know what voltage is because they don't mark it. Found a 3.3 volt rail here, which once again disappears if you've only got the battery installed. So yeah, we turn that off and it's gonski. Now normally we'd have to just keep tracing the circuit out like this, but I decided to check, hey, is there a service manual for this available? Is there a schematic? And I didn't have high hopes, but sure enough, here it is. I found it on Scribd. So thank you to whoever uploaded it to there. Oh, look, AC leakage test. Yeah, here we go. We've got some troubleshooting flow charts. Great. Okay. Device does not work. Please check the power flow as follows. As blow. Power flow as blow. Do not work. Insert AC power and press the power button to see if the machine can be started. No, it cannot. The first thing they tell you is the 5 volts okay. So if it's not, then replace U130. There you go. Unfortunately, this board doesn't have reference designators on it. So, well, the main logic board doesn't. The front panel board does. But interestingly, then they go on to 3.3 volts. And we did measure a 3.3 volt rail there. But it would only come on when you plugged in the mains. Okay, so yeah, so replace U84 or U5. So they've got a few things, but yeah, let's just go down here and see if we can find. They tell you how to take it apart. Fantastic. Ta-da! Block diagram. Look at that. Bobby Dazzler. That's not really the one we want. That's sort of like the operational one. Power. Here you go. Here's where we get the power switch in. Nice. So AC in here, 24 volts, yep. There's one diode going over to a MOS switch, which is an AP2309. 24 volts, we do know we're getting the 24 volts out, so that's okay. So the AP2309 MOSFET must be okay. And then the TPS 54302 is the 5 volt 3 amp. Okay, and then USB charge, power on. So that 5 volt's pretty critical. It powers a lot of other stuff. So yeah, we really need to make sure that 5 volts is okay. What is this 12 volts DC in over here? Was that thing on the back that I didn't know? Is there really an external DC in? But anyway, we do know that the battery charging works. So the BQ24773 chip there, they're using for the charging, we know that works fine. And then the AC power on, MOSFET AP2309. That's got guilty written all over it, hasn't it? That's AC power on and MOS cutoff. Whatever that means, but that could be like soft power kind of thing. So, yeah, because you want to power it from the battery. And that's the problem. It's not powering from the battery, but it works from, well, it doesn't work. It's not powering on. See, it's got multiple faults here. One is that we're getting 24 volts through to here. So, but something's not switching on. Yet we know plugging in the battery over here doesn't turn it on. So we could have multiple faults here. We could have this path here, which goes up here through this MOSFET here, and then we could have another problem, which is over here, which is actually switching the thing on. And down here, 19 volts to the amp. Weren't we measuring 18 volts somewhere? So that looks okay. Oh, look at this. They've even got currents. Look at that. That's nice. Wow. Leave it in the comments the last time you've seen like functional breakdowns of currents for each thing in that sort of format. Well, I can hardly read that dark blue, black on dark blue. Awful. But that's great, isn't it? Hats off, and we get our schematic. See, but the thing with all this is that the thing that's not working is the soft power on button, which comes from the microcontroller. It's like it's not like there's a front panel switch there that just like activates discrete circuitry like this, a MOSFET latch kind of, a power latch thing. So it's probably coming from sys enable over here. So if sys enable on, then that should turn on that MOSFET and should switch the 24 volts here, which we know is good, probably through to the 24 volt 1 amp down there perhaps. But yeah, so that's like a latching thing. Whenever you see like a control signal down here, then driving the gate of a series power MOSFET like that, it's kind of latchy. Latching functionality basically happens, turns on this transistor, turns on that one, and turns on the MOSFET. So it latches on. So and this logic line would come from the processor. So, and if we're not getting power to the processor, which we won't get in power to the keypad board, then yeah, we're going to Kamigutsa. Oh, got the whole shebang. This is great. Do we have like a component overlay as well? Because as I said, there's no reference designators. Geez, yeah. Yes, we do. Look at that. Absolutely fantastic. Because that, they didn't basically bother to print that overlay on the PCB. Yeah, so there's our 24 volts coming in, and we've done that. So yes, we can actually check. So we'll go back to the 5 volts. I'll find that and find the point 5 volts on this board, and we'll measure it. Oh, I just noticed, press 10 seconds to reset. So that's that reset thing. But as I said, those buttons, I did that button combination on the thing, and it didn't reset. But maybe if I force the 24 volts in, no, I did it when it was powered up. So, unfortunately, it didn't actually show me where the test points were, but I've searched for U130, so there's our 5 volt, power key. Look at that, But it's coming through that switching matrix, isn't it? Or is it separate? Does it come through? I assumed it was going through that multiplexer chip. I assumed it was going through that multiplexer chip on the main board. Does it not? Does it actually, maybe the power switch actually goes out on a dedicated line? Yeah, that'd make sense. Here's the problem. You got to trace this stupid thing, right? And I could have a look at the schematic, I guess. But oh God, and then I've got to go through multiple ribbon cables all the way back? No, how about I just go to the schematic for the connector on the main board perhaps, and see if there's a power on signal there. Now let this be a design lesson to you. When you're laying out your boards like this, put test points on, labeled test points on the PCB. I'm having a hard time tracing all of this. It looks like the keyword search doesn't find stuff on the overlay diagram here, and it's like it says measure 5 volts and then it doesn't tell you where to measure 5 volts. It is completely non-obvious. It's nuts. Just test points on your board, label them. See, now we're getting into the nitty-gritty of stuff, and we shouldn't have to do this if they simply had the PCB designer put test points on the board and labeled them. I'd be able to, right, there's all the rails. Go and systematically measure them. And we could have done that half an hour ago. You see, but the thing is, like, it's still this power key thing here, right? And VCC 3.3 volts, and there's a system VCC which is used for the input for the VCC 5 volts. So it's like, what the heck? And they say the first thing you do is measure 5 volts. Well, okay, so there's your sys VCC. Okay, so that is, sys VCC is the 24 volts. Okay, no worries. We know we've got that. So the 5 volts VCC will only get enabled when the power key is set. So copy and find and paste power key. Aha, what do we got here? Power key. Ooh, look at that. And that goes to power key. So I've got a couple of signal diodes here which pull that gate. Yes, which pull the gate down. So I think the power key might just literally come from all the way over that board, all the way over the ribbon cables. Okay, power key. Right, is this it? To keyboard. Yes, yes, yes. There you go. There it is there. Yeah. All right. So assumption, you know what they say about assumptions. They're the mother of all screw-ups, right? And I assumed that the power key came through active electronics, whereas that's not the case. So not having that power on that key matrix PCB didn't matter. That was chasing a red herring down a rabbit hole. So yeah, it's literally the power key, right? So there could be like a broken trace, a broken ribbon cable, or something like that. That could be it, right? Because there's an actual power key there. So it's pin 11, right? Wow, see, if I didn't have the schematic, I could have been chasing this down, you know, as I said, the old proverbial red herring down a rabbit hole. So yeah, but with a bit of hindsight, I guess, maybe that's the more logical thing to do. But, you know, my guess that we needed power on that I/O board to get the matrix wasn't bad, but turned out to be wrong. Oops. And this is where you can spend like hours troubleshooting something like this with a wrong assumption. So yeah, trust but verify. Yeah, so it's got an I2C line here for the LEDs, and the keyboards, it just reads those with ADC lines, so they're just different value resistors or whatever, and it just measures that, and sensor line or whatever. But yeah, there's literally a power key. Wow. Yep, there you have it. SW40. Now we should find our power switch is, sure enough, SW40. So there's a 220 ohm ferrite bead there. So we do know the switch works, okay? And it's just connecting it down to ground. That's it. So technically I could bypass that and I could force pin 11 down to ground, and that should switch it on. Maybe I should actually try that. Okay, so I've got it on ground, and I'm gonna short out that pin there. I'm using my multimeter in current mode. By the way, just a little tip there. Oh, winner, winner, chicken dinner! The LEDs change colour. Look at that. Yes, yes, look. We've got a whole bunch of green over here. It works. That's all it was. Wow. I don't think there's any semiconductor failures on here at all. The issue seems to be that they have actually run... Would you believe this? It's unbelievable. I wouldn't... once again, with hindsight, but I didn't guess this at the start. I made a false assumption that this switch was going through this key matrixy thing, which is getting like I2C signal through, and it's doing the LEDs. But yes, they are driving LEDs through on I2C, but this switch actually goes through 20 million jumper links, right? Back to a pin on here, probably pin 11 if they keep the pin number consistent. And then it goes over this ribbon cable over to here, and then it goes through here, and then it goes over to here, and then it goes over to here, and then it goes into the various power, you know, latch enable circuits that we actually saw. Wow, there you go. And so I don't think there's any semiconductor failures on here at all. I think we've just got a broken line in here somewhere. And if you remember right back, before I even took this thing apart, I suspected it would be the switch. It would be the switch. But of course, we buzzed out the switch and it worked. And you're not going to get a break in a PCB track going back to the processor. And I just assumed that the processor worked and the switch would have been connected into there. And then it would have been going back via the serial line, in I2C in this case. But no, dedicated line going all the way back. Unbelievable. There you go. So I've probably wasted like half an hour, or with edits, probably an hour actually, you know, mucking around here. It takes longer to shoot these videos, by the way, than it does if I would have normally troubleshooted this thing. But without the schematic, I probably would have kept going down the rabbit hole trying to work out, you know, how that circuitry was all switching, all the various things. And yeah, it would have been, I started reverse engineering the board. It would have been a pain in the butt, but there you go. Wow, that's an interesting fault, is it not? An actual, it looks like it's a mechanical fault, not an electronics fault. I finally get an interesting repair video for those who complain that I don't get interesting repairs. I usually don't get that lucky. So anyway, that's drawing 176 milliamps, just the logic board on its own, because we're not driving any speakery doodads or whatever. Anyway, we'll turn that off so we know how to get that turned on now. I've got to go through and search from pin 11 and all the way back. So if we search from pin 11 to here, there should be like 220 ohms of, well, that ferrite bead. Focus, you bastard. If we measure between there and the switch, yeah, we don't get anything at all. Just checking the ribbon cable there. That looks good, doesn't it? But yeah, you can easily get breaks in these ribbon cables, but usually not smack in the middle like that, and it's had no physical abuse. So 7, 8, 9, 10, 11. Is it broken on this board? Oh, maybe I can trace it. I think I got the right one. I think it's pin. I think they're keeping the pins consistent. I better double check that. I don't want to assume again. For those who want to see all those 0 ohm jumpers, look, the power key. One line for the power key has 6 0 ohm jumpers in there. 6. And they're all the same net. So electrically, they're all the same. So yeah, they don't put different nets on different sides. So yeah, that's just incredible. So it's got to go through 6 resistors. So technically, we could have a component failure if one of those 0 ohm resistors fails. Wow. I'm going to have to do it, aren't I? I'm going to have to... Ooh, is that a break? No, that's... No, it's not a break. It's just a residual. Is it? No. Put a bit of spin on that. That's not a break. Is that a break? Is that a break? Oh, no way. No way. No freaking way. A PCB break. No. It is. It's a damn PCB break. What? That is the last thing I would have expected, even after all this. That is the last thing. Hands up, leave it in the comments. Would that have been the last thing you would have expected? It would have been a physical PCB break. What? How? And it couldn't have been intermittent, because that looks like... just hang on. I just cannot believe this. Do we get, like, look, it goes there. Of all the lines, of all... Ooh, it's a bit... the case is a bit loosey-goosey on that. But of all the lines, it's broken. It's not the ribbon cable, it is the PCB. Come on, you have to give this video a thumbs up for a fault like that. That is insane. I swear I didn't do this deliberately. Like, I don't understand how this product could have worked with a break like that. How did it even originally work? I mean, there's sort of like this stain mark, which sort of like was in line, and you saw it before I wiped it. Yeah, look, there's a continuation of this mark that goes up there, but so I don't know what. Oh, look, it snakes around here. I was going to say, is this some sort of cable or something that was sitting on there? Oh, it's the rubber. It's the rubber. I've got it. I've got it. These rubber keys. I reckon that is the mark. That is the mark of the rubber membrane. What somebody's done is they spilled, and they've been using this thing at the pub, and they spilled some beer in here, and it's corroded. Sorry, it's eroded the trace down on the power of all the switches, of all the traces, the power switch. Unbelievable. What are the odds of that? Rather than, you know, going through all the ribbon cables, all that complexity, all these jumper links. And somebody has just spilt something, you know, there's something corrosive that's gotten in there. I reckon it's beer. Leave it in the comments down below. And has eaten away that trace. There's a little ferrite bead there. But why have they got 3? So I think we saw that on the schematic. So they haven't fitted the capacitor. They haven't fitted the ESD protection either. So they've just got the ferrite bead there. Oh, that's incredible. Wow. That's just really something else. Come on. Come on. Give me the thumbs up on this video. You cannot say anymore that I don't get interesting repair videos. Wow. This is one of the most interesting. Probably, you know, another one with that HP oscilloscope that time that had, oh, and a spoiler alert, I think it was a 2-parter video. I don't want to spoil that. That was a very interesting component failure in that one. We traced that down. So do we update our troubleshooting procedure from thou shalt measure voltages to thou shalt check for beer stains? Wow. This is great. So I'll just scrape away some of that trace there, and so we can get either side. I won't put a jumper wire. I think I'll put like just a jumper, a little bridge. Yeah, look at it. It's eating that away. Actually, that trace is really small. I didn't like that, so I might just put a little mod wire going over, I think. It'll be a bit neater and potentially more reliable, especially if the membrane is putting pressure, you know, down on that. I don't want the membrane to sort of like wear on that point. Yeah, and those traces are starting to lift as well. So yeah, I'll just get rid of those, and I'll just put in the jumper. Put some solder back on the well-worn thing over here, and we have a nice convenient pad there as well. There is our finished jumper, and we can now power this whole silly thing up again, and I betcha she's going to work now. Power on. There you go. Standby. Press the switch, and boom, changes color. Give it a few seconds, or the LEDs elsewhere will light up. It'll, yep, where were they, over here or something? Yep, oh, all green. Look at that. Fantastic. And there's green LEDs on the other board, and then we can switch it off as well. Put in standby, or do we have to? Yep, there you go. Goes into standby. That's all it was. Unbelievable. Winner, winner, chicken dinner. Wait, hang on. I forgot something. You remember the battery? Yeah, how it didn't do the battery thing? Well, let's plug the battery in, and sure enough, we get no standby or anything like that, but that's what you'd expect. So if we press the button, ta-da! It works. So we've got no external 24 volts on there now, and boom, and it's given us the charge level there from the battery. Yeah, everything's hunky-dory. It works now. So unless there's another fault with the audio, once I put this all back together, it should work just fine. And what I'll do, just to stop rubbing on there, I'll put some capped on tape over that. So yeah, that will just help prevent the membrane from like rubbing on that. So yeah. And interestingly, there's no evidence of any spillage in there, but that's what it's got to be. So, because there's some residue on the board, as you saw. So yeah, maybe it's just seeped around the edges there. I don't know, somehow. I don't know, or is it factory contamination? Before I assemble all the panels and everything back on, let's try it. I think I've connected everything up. So, connect our power switch. Oh yeah, yep. Flishy flash! Flishy flash! Look at this! Winner winner chicken dinner! And you heard it, it had the power up thing. I'm pretty sure the rest of it's going to work. That sounds like a winner to me. Who's that annoying dude? Oh, what are these LEDs on the outside? Look at that, what? Anyway, it's got like a wanky like figure 8 PCB. They have actually changed the continuity in this version 11 compared to the version 9. And you'll notice that is... So that sounds great. I declare that repaired. So there you go. I hope you enjoyed that very interesting repair video. Very interesting fault. Not something that you probably would have guessed at the start of the video or even midway through. Leave it in the comments down below. When did you spot it? Is it the same time as me? So there's quite a few lessons in there. I probably overthought that in the terms of like tracing the power button and stuff like that. Because that was my initial assumption. I reckon it's just the soft tactile power button, but due to some sort of contamination from the rubber, unbelievable. I mean, wow. Wow, I never would have guessed that, but my original hunch was actually correct. And then I made a huge assumption and chased a red herring down a rabbit hole, assuming that it was, you know, digital interface was to that front panel PCB was fine, but nope, wasn't that. Just through 6 jumper links and 3 ribbon cables going back to the main board. And it turned out none of that, and none of the ribbon cables failed. It's a damn PCB. Unbelievable. That's quite an unusual one, so I really love those ones. Sometimes you get a win, so definitely give that a big thumbs up. And as always, discuss down below. And you can get my merch over on the EEVblog.store as well. Fantastic. Catch you next time.